Yes, good morning friends. Our today's experiment is to observe the attenuator characteristics with the help of microwave test bench. So to study the attenuation characteristics with the help of variable attenuator is our objective. So whatever the equipments we needed, it is Klystron power supply, Klystron tube, Klystron mount, isolator, frequency meter, variable attenuator, detector mount, then waveguide stands, VSWR meter and BNC cable. So here you are observing a Klystron power supply, then it is Klystron, then Klystron mount, then cooling fan is there, isolator is there, variable attenuator. So we are observing or doing the practicals with the help of this variable attenuator. So it is our basic important component for this particular practical. So frequency meter is there, then slotted line, then BNC connector itself gets connected to your CRO, so cathode ray tube. So let us have a look over the block diagram for the attenuator characteristics. So Klystron power supply gets connected to the Klystron mount, then it is connected to the isolator, variable attenuator, frequency meter, slotted line, detector mount and CRO. So it is Klystron power supply gets connected to the Klystron with the help of Klystron mount, then through fringes nut bolt arrangement the Klystron mount get connected to the isolator. So during forward journey the signal gets transmitted from your reflex Klystron to the remaining test bench setup, but during reverse journey no signal will be forwarded towards the Klystron supply because this isolator isolate the back energy or the reverse energy. Then variable attenuator connected to the frequency meter, then it is connected to the slotted line, and finally it is connected to the detector mount and to the CRO. So this is your basic experimental setup you are observing, right? Now let us have a look over the attenuator characteristics of this setup. So dear students, our first aim is to observe the square wave on the CRO. So first of all I will make the Klystron power supply on and put this meter select switch to the beam voltage position, these two knobs at the center position. Now beam voltage knob, it is fully anti-clockwise direction, and repeller voltage knob fully clockwise direction. So at initial conditions the beam voltage itself available on this Klystron power supply, it is 201 volt. So it is necessary that this particular voltage range is up to 200 volt. So we are observing here 201 volt, right? Now whatever the modulation selection it is of AM here, so I have selected amplitude modulation knob here, right? Okay. Now our next step is that increase the beam voltage up to 300 volt. So I am increasing it up to the 300 volt. So 298, 300 volt. So it is 300 volt. Now once the 300 volt itself gets observed, I will wait for 1 to 2 minutes so that our Klystron will respond, and the square wave itself we observe on the CRO. Now dear friends, in this particular practical I already said that this particular variable attenuator is the basic important component, because with the help of this particular component I am changing the attenuation, and just by changing the attenuation I am going to observe the changes in the output voltage. So if there is zero attenuation, what is the output voltage? If there is maximum attenuation, what is the output voltage? That changes we have to observe. So if we go through the observation table. Here you are observing observation table. So micrometer reading, so 1 2 3 4 5, and the output voltage. So for the first micrometer reading, so at suppose no attenuation position, what is the output voltage? That output voltage I am taking as a reference. So suppose V0 is the output voltage which I am taking as a reference. Then I will change this attenuator from 0 attenuation to some attenuation position. So at the initial condition, suppose this knob is at 25, then I will change it to the 20, then 15, then 10, then 5, and then I will observe the changes in the output voltage. So suppose V0 is your reference voltage. Now suppose next value it is V1, then attenuation at V1 in dB is equal to 20 log of V1 by V0 in dB. So I know the value of initial reading, first reference reading, that is V0, then V1 after changing the attenuator position, then I will calculate the attenuation in dB. So for different types of micrometer readings on the attenuator, I will observe the different attenuation values, right? So now I will change the beam voltage to the 265 volt. So I am just reducing it to 265 volt. So 267. Okay. Okay, 267 is also okay. Then I will just change the repeller voltage so as to get a square wave. So dear students, here you are observing a square wave on the CRO, right? Now if we change the AM knob, amplitude knob of AM for the maximum output voltage, okay, so this is the maximum output voltage I am observing here. Also through the slotted line I am changing the knob. So here you are observing there is output reduction in the output voltage, right? So minima and maximum points we are observing. Yes, so it is the maxima point where I am getting the maximum output voltage, right? So I will adjust. So output voltage it is 3.2 multiplied by 0.5. So it is 1.6 volt approximately. Okay, so this is the basic experimental setup. Now dear students, whatever the value I am taking here, it is 25 millimeter. So attenuator, variable attenuator is giving or showing me the value of 25 millimeter here. So it is extreme outside. So for 25 millimeter, the output voltage value, it is suppose 1.6 volt, right? Now if I will change the attenuator position and I will go for the increase in the attenuation, we will observe that the voltage attenuation takes place. So I am just reducing it. You will observe here the output voltage change. Yes, here you are observing as I am increasing the attenuation, the output voltage goes on reducing, right? So just I am changing it to the maximum position, the output voltage gets changed, right? So suppose the first reading I will take, suppose at okay, so 5 micrometer. So here you are observing 5, just a minute. Okay, so you are observing 5 micrometer. Now if I will increase, so on this particular scale it is 5. Yes, here you are observing 5. So for 5 micrometer, the output voltage is now 2.4 multiplied by 0.5. So it is 1.2 volt approximately. So for the micrometer reading 5 millimeter, suppose V1 is 1.4 volt, right? So I know the value of V0, I know the value of V1. So attenuation for V1 it is 20 log of V1 by V0 d3. So I will put the value of V1, put the value of V0 and calculate the attenuation. Once again for the next reading, so suppose if I am taking the reading at 10 millimeter, I will note down the next value of output voltage, that is V2. So it is V2 by V0, so attenuation at V2 in dB. So different readings I am taking. So 1, 2, 3, 5 readings we have to take. So this is the common procedure to calculate the attenuation in with the help attenuation characteristics with the help of your microwave test bench. So this is your variable attenuator. So extreme outside position it is 0 attenuation, extreme minimum position it is highest attenuation. So for extreme outside position we are getting some output voltage, so which is approximately 1.6 volt, and at extreme minimum position we are getting some output voltage. So just see here, you are observing I am changing the output voltage. So just a minute. Okay, so changing the output voltage to the minimum position. Okay, so one certain level will reach. So this is the exactly minimum position. So for that the output becomes 0 or some minimum value. So for getting the output we have to put your attenuator knob to the extreme outside position. So just by knowing the values of different micrometer readings, so 25 micrometer or millimeter, 5 millimeter, we can calculate attenuation in dB. So this is nothing but observation table and calculation procedure for finding out the attenuation at different voltage level. So we will stop here. So thank you very much.